Astronomers, there is life on this planet and we'll see it soon. As the 20th century began, interest in the potential of life on Mars and the possible civilizations there led to a search for signals. Could we communicate with another planet? How might we look for signals and messages from other worlds? Come on, let's find out. Welcome to our channel Space Venture. In today's video, we're going to talk about life on other planets. The ultimate goal of NASA's exoplanet program is to find faint signs of life on a planet beyond Earth. How soon that might happen depends on two unknowns: the prevalence of life in the galaxy and how lucky we are as we take those first, tentative exploratory steps. Our primary planet-finding missions, such as NASA's Kepler and its extended Avatar, K2, or the upcoming James Webb Space Telescope, may provide bare-bones evidence of potentially habitable worlds. James Webb, designed in part to investigate gas giants and super-Earths, may find a larger version of our planet. NASA's Nancy Grace Roman Space Telescope, or Wide-Field Infrared Survey Telescope, can zero in on the reflected light of distant planets to detect oxygen, water vapor, or some strong indication of possible life. But if we're not lucky, it may take decades to find signals of life. Another blue-white marble hidden in the star field, like a grain of sand on a beach, will likely require a larger imaging telescope to discover. Design is already underway for a next-generation planetary explorer in the 2030s or 2040s. MIT physics professor Sarah Seeger is looking for possible chemical compounds that could signal the presence of alien life. He and his biochemistry colleagues first focused on the 6 main elements involved in life on Earth: carbon, nitrogen, oxygen, phosphorus, sulfur, and hydrogen. "We're going to have so few planets, we have to get lucky," Seeger said. "I don't want to miss anything. I don't want to miss it because we aren't smart enough to think of some molecule. But the big question is there life beyond Earth?" An irony comes with an asterisk. We don't have an universally accepted definition of life. That said, we may not need one. We just need to detect subtle signs of life in an exoplanet atmosphere and better understand what they look like on Earth. The James Webb Space Telescope, launching in 2021, may get the first glimpse: a mixture of gases in the atmosphere of Earth-sized exoplanets. Webb, or a similar spacecraft in the future, could pick up signs of an atmosphere like our own: oxygen, carbon dioxide, methane, a strong indication of potential life. Future telescopes may even pick up signs of photosynthesis, the conversion of light into chemical energy by plants, and even gases or molecules that suggest the presence of animal life. Intelligent technological life could make atmospheric pollution, as it does on our planet, detectable even from afar. Of course, we may be able to manage an estimate of probability. Still, with an exoplanet, say a 95% chance of life would be a game-changer of historic proportions. Life could have arisen around us, beneath the Martian surface, perhaps or in the dark subsurface oceans of Jupiter's moons, Europa. Or maybe the dreams of the ages will come true, and we'll hear about communications from extraterrestrial civilizations. We can even find evidence of techno-signatures. Barring these strokes of luck, however, the task would be much more difficult. Light will be the key. Light from exoplanet atmospheres splits into a rainbow spectrum that we can read like a barcode. The method, called transit spectroscopy, will provide a menu of gases and chemicals in Earth's atmosphere, including those associated with life. They live in a caustic chemical pools in Yellowstone National Park, in dry valleys in Antarctica, in superheated vents on the ocean floor, and belong to branches of life that diverged from us billions of years ago. Extremophiles are of life forms that love extreme environments, thriving in conditions that kill anything else. They may be also analogs for strange life in distant worlds. More than 4,900 exoplanets, planets around other stars, have been confirmed to exist in our galaxy, but their number is likely in the trillions. One of the best tools scientists have for narrowing down the search for habitable worlds is a concept known as the habitable zone. It is the orbital distance from a star at which the temperature would potentially allow liquid water to form on the surface of a planet. Several other conditions would be required: a planet of suitable size with a suitable atmosphere and a stable star that is not prone to exploding in sterile craters. The habitable zone is a way to make the first cut and zero in on planets with the best chance of having habitable conditions. The definition of a habitable zone is the distance from a star where liquid water could exist orbiting the planet's surface. Habitable zones are also called Goldilocks zones, where conditions can be just right, not too hot or not too cold for life. When searching for potentially habitable exoplanets, it helps to start with worlds like our own. But what does similar mean? Many rocky planets have been detected in the Earth's size range, a point in favor of possible life. Based on what we've observed in our own solar system, large gassy worlds like Jupiter seem far less likely to offer habitable conditions. But most of these Earth-sized worlds have been detected orbiting red dwarf stars. Earth-sized planets in the wide orbits around stars like the Sun are much harder to detect. And of course, when talking about habitable exoplanets, we're talking about their stars, the dominant force in any planetary system. Habitable zones are capable of hosting life-bearing planets or wider for hotter stars. Smaller, dimmer red dwarfs, the most common type in our Milky Way galaxy, have much tighter habitable zones as in the TRAPPIST-1 system. Planets in a red dwarf's comparatively narrow habitable zone, which is very close to the star, are exposed to extreme levels of X-rays and ultraviolet UV radiation, which can be up to hundreds of thousands of times more intense than what Earth receives from the Sun. An old joke offers an answer. Asked why on a night he was looking for his missing car keys beneath a street lamp, the man answered, "Because the light's better. Life on other planets might be like nothing on Earth. It could be life as we don't know. But it makes sense, at least at first, to search for something more familiar. Life as we know it should be easier to find. And the light's better in the habitable zone or the area around a star where planetary surface temperatures could allow the cooling of water." Other similarities to Earth come into sharper focus in the search for life. Many rocky planets have been detected in Earth's size range, a point in favor of possible life. Based on what we've observed in our solar system, large gaseous worlds like Jupiter seem far less likely to offer habitable conditions. But most of these Earth-sized worlds have been detected orbiting red dwarf stars. Earth-sized planets in wide orbits around Sun-like stars are much harder to detect. Yet, these red dwarfs have a potentially deadly habit, especially in their younger years. Powerful flares tend to erupt with some frequency from their surfaces. These could sterilize closely orbiting planets where life had only begun to get a toehold. That's a strike against possible life. Because our Sun has nurtured life on Earth for nearly 4 billion years, conventional wisdom would suggest that stars like it would be prime candidates in the search for other potentially habitable worlds. G-type yellow stars like our Sun, however, are shorter-lived and less common in our galaxy. Stars slightly cooler and less luminous than our Sun, called orange dwarfs, are considered by some scientists as potentially better for advanced life. They can burn steadily for tens of billions of years. This opens up a vast timescape for biological evolution to pursue an infinity of experiments for yielding robust life forms. And for every star like our Sun, there are 3 times as many orange dwarfs in the Milky Way. So, this is all for today. Hope you enjoyed the video. Do like, share, and hit the bell icon for future updates. See you in the next video.